So today we're going to be talking about operations with polynomials. So first of all, we need to define what it means to simplify an expression. And so to simplify an expression containing powers means to rewrite the expression without parentheses or negative exponents. So first of all, we have no parentheses, no negative exponents. That is our utmost goal. Another thing is that we need to make sure that if it's in fraction form, it's reduced down to simplest terms, so that there's not like an n on the top and an n on the bottom. Okay, so now we're going to review these properties of exponents, and this is in your book on page, what is it, 303. Okay, so if you want to turn there, that's fine. Otherwise, you can follow along up here on the board. But these are properties of exponents, and you need to make sure that you know what these are. Okay, so yeah, it might be a good idea to write these down. But like I said, it's on page 303 in your book, so you can either look there and follow along, because this is the exact same table that's taken from there. But the first one is what happens is when you have a product of powers. So basically, if you would have like 3 squared times 3 to the 4th, as you see in this example, the question is, what do you do with the 2 and the 4? What do you do with those exponents? And what you do is add them together. Now, you get to a test and you blank and you're like, I don't remember what I should do here. The easy way is that if I have 3 squared, we know that 3 squared means 3 times 3, right? I mean, that's what 3 squared is. It's 2 3s. We know that 3 to the 4th means 3 times 3 times 3 times 3, 4 times. So what you can do then is you can say, oh, well, I have 1, 2, 3, 4, 5, 6. So I have 6 3s. And that's where 3 to the 6th comes from. And on tests, when I was in your position, that's actually what I did. Okay, I at the top of my test went through and I wrote this and I was like, oh, well, that's what it is. Because I could never remember, do I add or do I multiply? If you divide, on the other hand, instead of adding, you subtract. And so when we think about test time, once again, 9 to the 5th means you have 5 9s on the top. 9 squared means you have 2 9s on the bottom. So really what ends up happening is that you can cancel out a set of 9s here, you can cancel out a set of 9s here, and if you look, that means you have 3 9s left. So that's another way. You forget come test time. Write it out quick, do something like that. A negative exponent, remember for a negative exponent we flip it. So if the negative exponent's on the top, we move it to the bottom. If the negative exponent's on the bottom, we move it to the top. Power of a power. This is where you multiply the 2. And you've already seen these before, so this should be reviewed. So if some of you are thinking it looks familiar, it should. Okay. 3 cubed squared. What that means is that you're going to have 3 cubed times 3 cubed. And then you can use the power from up, or the property from up above. Or you could say, this means I have 3 3s. This means I have 3 3s, which means I have a total of 6 3s. Power of a product, basically the biggest thing here is you need to make sure you distribute to both terms here. Just like here in 2k to the 4th, you have to distribute the 4 to both the 2 and the k. Power of a quotient, once again, you have to distribute that power up above and below. And if you have a negative power like we did here, there are 2 ways to do that. One, you can distribute the negative to each, or what you can do is make it a positive first by flipping it. And we'll look at an example of that as well. And then last but not least, the 0 power. Anything to the 0 power is always 1. So it could be 1,000,000 to the 0 power, and your answer will still be 1. All right, so now what we're going to do is we're going to look at a few examples. All right, so our first, okay, before we look at an example, and this is kind of what we talked about on that first slide, but I want to be clear what you need to have. A monomial expression is in simplified form when there are no powers of powers, when each base appears exactly once. So that was the thing with the variables. When all fractions are in simplified form, and there are no negative exponents. Okay, so no powers of powers. Each base appears exactly once. All fractions are in simplest form, and there are no negative exponents. Okay, can't have negative exponents. Alrighty, so what we're going to do is jump right in with an example now. And you should find out that today's assignment should be some review from what you've had in the past. So it says, simplify each expression, assume that no variable equals 0. So that's what the instructions are always going to be on your homework today. So simplify. So that's what you can put if you're writing this down. Simplify. And then write this expression down. And then we'll talk about how we simplify this. The first thing we're going to do is we're going to look at coefficients. And so we're going to kind of break this up. So I'm going to start with the coefficients. So notice I have a coefficient of the 2 and a 3. And the coefficient here is actually a 1 even though you don't see it. So all I'm going to do is I'm going to take 2 times 3, which is 6. Okay. Then what I'm going to do is I'm going to look at my next variable. My next variable here is a. And then notice I've got an a here. I don't have an a in the last one. So I've got an a to the negative 2 and an a to the positive 3. What's the net result going to be? A. Yep, a to the first. Or just, you could put a. Because negative 2 plus positive 3 is 1. Now what I'm going to do is I'm going to do the same thing. I'm going to look for the next variable. Next variable I see is b. Do I see another b? Nope, so I'm going to leave it as b squared. Next variable you see is a c. I have c to the negative second. Now we've got a problem. What's our problem? You can't have a negative exponent, so I have to figure out another way to write c so that it's not negative. Ideas? Move it to the bottom. So 6ab squared over c squared, and that is your final answer. That's all you need to do. So we're going to break things apart, look at things individually, and it should be fairly straightforward. So let's go ahead and look at this next one. Okay, q squared r to the 4th over q to the 7th r cubed. So now what I like to do is I like to visualize this in my head. So what this means is that I have 2 q's on the top. And I have how many q's on the bottom? 7. So where do you have more q's? On the bottom, right? And so when I think about that, how many q's do I have? What would my net result be? 5 q's where? On the bottom. So I've got a q to the 5th on the bottom. So I've looked at my q's. Next ones I'm going to look at are the r's. So you have 4 r's on the top, 3 r's on the bottom, right? So what's your net result going to be? 1 r on the top. Yep, there you go. Now for those of you that weren't getting when I said you should visualize it, when I meant the r's, when you've got 4 r's, that means you have this, and 3 on the bottom. So you cancel them out, yep. So you cancel these out, it's going to leave you with 1. All right, let's look at the next one. Oh, this is a power to a power. Yep, take them all to the 3rd power, yep. So I've got this to the 3rd, this to the 3rd, and this to the 3rd. So really what that means is you've got negative 2 to the 3rd power. You've got a to the 4th to the 3rd power. You've got b squared to the 3rd power. And you're going to get to the point where you won't have to put this purple step in. I'm just putting this in so you can see how things go. But you should be able to look at that and give me your answer. So if I cube negative 2, now notice the negative stays with the 2. So it's like negative 2 times negative 2 times negative 2. What's your net result? Negative 8. Good. So now a to the 4th to the 3rd power. A to what?
7.
A to what? 12.
Oh, yeah.
The reason why it's 12, remember, a to the 4th cubed means a to the 4th times a to the 4th times a to the 4th. So you have 4a, 4a, and 4a, which is 12a. On the bottom, what do you get b to what power? 6. Okay, because you have 2 times 3, which is 6. Okay, last one I think we're going to look at in this part. we're going to look at some more. So can somebody tell me what my first term will be in my answer? Negative what?
Oh, negative 14.
Negative 14, because remember, I'm going to start with the coefficients, 2 and negative 7. So 2 and negative 7, if you multiply those, because those are numbers, you get negative 14. Can somebody tell me what the next term is going to be? X to the what power? Second. Because you have x to the negative 3, x to the 5. Add them together, you get positive 2. What's the last term going to be?
Y to the negative 3.
Y to the negative third. And we can't have that. So our answer will be negative 14x squared over y cubed. So they should be fairly straightforward. What we're going to look at now is, what happens when you have a negative power? Ideas as to what you should do. Yeah.
Take them and then switch them around.
Yep. In fact, that's what I would recommend you do. Flip the fraction and then make the exponent positive. It makes it a lot easier to start with. And then what I'm going to do is I'm going to distribute that power to each. So really I end up getting 4 cubed over a cubed. What is 4 cubed? 64 divided by
A cubed.
a cubed. There you go. That's it. So these problems don't take an incredible amount of time, okay, but you just have to know a lot of rules. So on this next one, this is real similar to that last one we just looked at when we multiplied, except for now we are going to divide. So what we're going to do is break this down individually and look at the individual components. So we're going to look at the coefficients first, then the next set of variables, then the next set of variables. So first of all, I've got the 15, negative 3. What is 15 divided by negative 3? Negative 5. Now this next one, I have c to the 5th on the top, c squared on the bottom. So think about it, 5 c's on the top, 2 c's on the bottom. C what? C cubed. Okay. And then let's look at the next one. We have d's. D cubed on the top, d to the 7th on the bottom. So 3 d's on the top, 7 on the bottom.
D to the 4th on the bottom.
D to the 4th on the bottom. Good. There you go. Questions? All right, so now we're going to talk about a degree, and now you're going to get to use the expression shortly after we look at this next one. The degree of a polynomial, it's the power of the term with the highest power. Okay, so that kind of sounds confusing, but what we'll do is break that down and look at things individually. So it's the power of the term with the highest power. So what you're going to do is go to the highest power in the problem. Okay, you're going to say, okay, this is the highest power. What you're going to do is look at that power, and that's the degree. So on this one, it says determine whether each expression is a polynomial. So you're probably wondering, well, what is a polynomial? A polynomial, first of all, can't have any negative exponents. Okay. The other thing a polynomial must have, it must all have terms with individual powers. Okay, and the powers must be whole numbers. So we're talking about x, x squared, x cubed, x to the 5th. Okay, so no negative exponents, and then you have to have like x squared, x cubed. So if you look at this one, okay, yeah, the 1/4 is a fraction, but that's okay, because that's just a number. That's like 0.25, right? And then you have x to the 4th, y cubed, so this is fine. Minus 8, that's fine, x to the 5th. So this is in fact a polynomial. So this is yes.
What would?
And we've kind of looked at polynomials before. You'll see shortly. You're saying what would one not look like, right?
Mhm.
Okay. So then now it says, if it is a polynomial, state the degree. So what is the term with the highest power? Is it going to be this one or this one? What do you think? I will tell you right now, it's the first one.
What?
Oh, do you add?
Why? Yeah. Why is it the first one? Because you have two exponents here, right? What's the power if you add them together? 7. So this is actually a polynomial with degree 7. So what you're going to have to do is add the exponents together, and that will give you the degree.
So
All right.
like you wouldn't add the x and the x?
No. Nope. Because the term is actually the x to the 4th y cubed. So let's look at this one. Is this a polynomial? Now, if you don't know, take a guess. If you don't know, take a guess. You've got a 50-50 shot. So think about what I said about polynomials. And take your previous knowledge, because we did look at polynomials last year in Algebra 1.
Oh. That looked like it hurt.
Ah, I'm actually really surprised. The majority of you got this right. So, because I was thinking first one. Okay, for those of you said that's not a polynomial, why not? The square root, that's exactly right. If you didn't catch what I said, x squared, x cubed, x to the 4th, you can't have the square root in there. Okay, here you go. Let's try this one again. Tell me what you think. Is this a polynomial? Yes or no? Ooh.
What? No. How is that
Oh,
not?
what?
How is that not yes?
Negative. So let's go ahead and look. Why is this not a polynomial?
Negative exponents.
The exponents are negative. If you remember what I said, x squared, x cubed, I never said anything about negatives. And in fact, I said no negative exponents. I kind of slipped that in there as well. Is this a polynomial? Here you go. What'd you put?
Cool.
Yes. What is
I keep playing yes, hoping that the
Wow, this one really threw you for a loop. We had a few of you put that no. Why no?
Because the fraction.
Because the fraction, if you remember what I said, you could have a fraction with a number, but you cannot have a fraction here. And this is the thing. If I were to write this so that it had no fraction, this would really be x times y to what power? To the -1. And we just learned on the one before that we can't have a negative exponent. Yes?
The one that this one that you wrote down, that's a fraction.
It's a number as a fraction, but not a variable.
So you can't be like x over y.
Right. Okay, so last but not least, this is the last thing we're going to cover. We're going to cover adding, subtracting, multiplying, and dividing polynomials. Okay, so the last thing today, and today I know it's a big lesson, but this is the last thing. And you're going to find out that this is fairly straightforward. We did a lot of this in Algebra 1. All we're going to do is add, subtract, multiply polynomials. So on the first one, what do you think? You guys have had me long enough to know. What do you think I'm going to tell you to do on the very first one? Switch the signs, because we always make mistakes when we subtract. Okay? So switch those signs, and then now all we're going to do is add like terms.
Cool.
So I'm going to add 4x squared and negative 2x squared. And I get 2x squared. I'm going to add negative 5x with what? And I'm going to get negative 8x. And then last but not least, I'm going to add 6 and 1, and I'm going to get 7, and there you go. With that in mind, I want you to do the next one for me. Okay? Do the next one for me. Should be fairly straightforward. Shouldn't take you a whole lot of time. You might not even need to write the problem down. Okay, so you should have started off with an x squared term. What is the coefficient of your x squared term? 2. So that should be your first term, 2x squared. Next, we have a coefficient of x. What is that coefficient of x? 2. Then we have a number right here. What's the number going to be? Plus 3. There you go. That's it. That's all you have to do. Okay? Adding and subtracting. Now, we've got one last problem we need to look at. We have one last addition problem we need to look at. So now, how do I do this? I've got an x squared. What do I add it to?
Nothing.
Nothing. So I leave it 3x squared. What will come next?
Negative x.
The negative x. Good. Okay. And then, what do I have? Minus 5. So just because I don't have everything included, I don't have 2x squared, don't have 2 x's, you can still add them together. Alrighty, the bottom one. Yep, that's all I'm going to do. Distribute.
That makes it 6x cubed.
That makes it 6x cubed. Okay.
Plus
Minus 12x squared. And then what?
plus 18x.
18x. That's all you do. Distribute. Okay, we've got
That looks like pain.
two more to look at. Two more to look at. Okay. Now this one looks way worse than it actually is. And the reason why it looks worse is because you don't like that 4/3.
Not pot on.
Okay. Actually, it is.
But the 3 would be a negative.
But it's a number, not a variable. Remember, it's all about variables. So now this is what we need to do. I'm going to take 4/3 times 6. What's 4/3 times 6? 8. So I have 8x to what power? The 4th. Okay. Next one, I'm going to take 4/3 times 9. What's 4/3? 12. X to what power? The 3rd. Minus. What is 4/3 times 12? 16. What's my power?
X squared.
There you go. So see, that wasn't near as bad as what it looked like. The last two. Taking forever. We're about done. This is our last slide today. I know it was a long lesson. Now you can see why we didn't do this the day before break, our day when we got back from break.
Oh, that would have been torture.
Okay. Now, this one you won't use FOIL on because it's not 2 terms times 2 terms. So this is what you're going to do. You're going to start by taking n squared times each of the 2. So if I take n squared times n, I get n cubed. If I take n squared times 2, I get
2n.
2n squared. Now you're going to do the same thing with the 4n. So I'm going to take the 4n times n and the 4n times 2. So what is 4n times n? 4n squared. What is 4n times 2? 8n.
8n. Oh my gosh.
Then I'm going to take negative 6 times n
What?
and negative 6 times 2. So what is negative 6 times n?
Negative 6n.
Negative 6n. What is negative 6 times 2? Negative 12. Now, if you've done this correctly, you should have 6 individual terms because you're taking 3 terms times 2 terms. So then now let's combine like terms. Okay, so what's my first term going to be? N cubed plus,
6n squared
okay,
plus 2n minus 12.
there you go, that's it. So see, that wasn't that bad.
How do you know when to do that though?
When
What
you have
is-
3 terms times 2 terms or 2 terms by 3 terms. So real quick, this is our last problem we're going to go through. Okay? 2x squared minus 4x plus 5 times 3x minus 1. So I'm going to start by distributing my 2x squared to each term. So here and here. And what does that give me?
6x
6x cubed minus,
12x squared.
I think it should be 2x squared.
5.
Yep. What should my middle term be? Here. What should that one be? Negative 12x squared
Oh, I
Plus-
didn't do that yet. I jumped to the next one.
4x. And then our last term should be 15x minus 5. So what's our final answer going to be? The last problem today. 5 times negative 1. 6x cubed minus 14x squared. Good. Okay, there we go. Lots of information today. Here you go.
Oh, goodness gracious. Oh, come on now. That's not
16 through 48, the evens, and 52 through 60, the evens for tomorrow. Okay? So,